Okay, hi everyone. So in this video, we'll teach you how to add two non-parallel vectors using a graphical method. Basically, that means by drawing it out. Okay, so we have a block here. There's two forces acting on it, a 6 Newton sideways and a 4 Newton upwards, right? So of course, we can use it to solve it by by calculation using Pythagoras theorem, but we're going to stick to using a graphical method to solve it. So there's more than one way to solve this. And so we're going to use the head to tail method, or sometimes we call it the triangle method. So before we do that, we probably want to start by sketching out how it may look like. So that gives us some idea how to plan the space that we have when drawing. So we're going to do a triangle method, which means that we're going to use the 6 Newton here, and we're going to be moving the 4 Newton such that the head of the 6 Newton is joined to the tail of the 4 Newton. So it's going to be something like this, right? And then join the tail of the 6 Newton to the head of the 4 Newton. This is from the start to the end. So the start of by adding this 6 Newton and this 4 Newton, we get this. This is the start, this is the end, this is the resultant. And this is the force that we want. So it kind of forms like a triangle. And this double arrow is our resultant force, which we want to find. Okay, and then this is the angle we want to find. So we're going to be drawing something like this in the space here. So we begin by first choosing an appropriate scale. If I choose, like, we can just start off on something random, maybe 1 cm to 1 Newton. That will be about 6 cm. 6 cm is like this small here. So it's not really, it's going to be ending up, the final diagram is going to be about this size, which is a bit small. So we can try to make it bigger. So maybe 1 cm represents 0.5 Newton. So I can have up to 12 cm here. And that seems to be like a good size for here. So I'm going to write down my scale. 0.5 Newton. And this is what we'll be using for this question. So let's begin. The first thing I want to do, usually when I start off with a diagram, a vector diagram, I would want to start with a reference point. So in this case here, because it's a straight line, I'm going to just do a straight line all the way, starting with a random line, marking my starting point. So this is where I can begin. Next, I will then realize that my 6 Newton I'm going to draw is 12 cm long based on my scale. So I'm going to use the drawing compass. I'm going to put it at 0 and stretch it all the way to 12, like this. So you can see here, this is 12 cm long. Once that, I put it at my starting point, and I'm going to do a arc. So it's very important that the pencil markings are sharp and thin so that the drawings can be more precise. So this is my first point, right? I probably can erase the rest or just dot out the rest. So this is my first force, 6 Newton, from this point to this point, and I represent it by an arrow to show this is my force. The next thing I want to draw is my 4 Newtons upwards, and I know it's 90 degrees. So I'm going to take this point as my reference now, and I'm going to find 90 degrees from this particular point. So this is my protractor, and this is 90 degrees. I'll put a marking here, and I'm going to extend my line. So it's always good to have a plastic transparent ruler to help you, because you can see behind the ruler. Helps in drawing. I think I'm a bit off, but I should be fine. Okay, the next, so this force I'm drawing is actually a 4 Newton force. So 4 Newtons, 1 cm to 0.5, I'm having it at 8 cm. So I'm going to reduce this back down to 8 cm. Somewhere here it's 8 cm. Okay, and then I'm going to mark it at my starting point. It's reference point, sorry. And then marker. Oh, looks like my line is not long enough. I'll extend my line. Let's put it a bit higher. Extend this line, like so. Okay, and so down, this is my second force at 4 Newtons. So I have already joined my 6 Newton and my 4 Newtons force. So how do I find my resultant force? I do from my start to the end. So there will be a resultant force from here all the way to here. Draw it with a solid line and then representing it with a double arrow. So this is my resultant force. And so what I want to do now, to find the magnitude, I will measure the length. So using my ruler again, measuring this is at 14, looks like 14.5. We're gonna round off, it's 14.45, 14.5, okay. So I'm gonna put in brackets 14.5 cm. And from here, I'll need to calculate 14.5 times 0.5 newtons. That is about 7.2 to 7. Let's go and round off 7.3 Newton. So that is how to find my resultant force. The next thing I want to do is to find the direction. So at the direction matters because all vectors have magnitude and direction. So I'm going to find my angle here. I'm going to measure it using my protractor. And from here, make sure you read correctly. So this is the 0 that we want. Coming up here is 30, 31, 32, 33. Looks like it's 34. Based on this angle, it's 34. Okay, so 34 degrees. So how would you represent your answer? You say the resultant force, in this case, will be 7.3 newtons. And the angle AS is 34 degrees from the horizontal. Or you can say, in this case, from the 6 Newton force. Okay? So this is how you draw for this question.